At first light, the tower looks less like a mountain than a surface that was interrupted. Vertical grooves run from the summit to the base, as if something fibrous once rose there and was torn away, leaving only the hardened inside. The walls do not slump like a hill. They do not spread like debris. They stand, ribbed, sectioned, exposed. From a distance, it is called a butte, a plug, an igneous remnant. But close enough to see the lines, close enough to feel the repeating texture, it begins to resemble something else entirely. Not a peak, not a dome, a cross-section, a remaining core, a stump so large that scale itself becomes the first barrier to believing what the eyes are showing. The accepted explanation is simple. These formations are said to be volcanic intrusions, magma forced upward into weaker rock. I see later revealed by erosion after the surrounding material wore away. In that account, the columns are cooling fractures. The flat top is coincidence. The steep sides are durability. Time, pressure, uplift, and weather did the rest. It is the kind of explanation geology is built to prefer, because it is clean, category-driven, and mechanically familiar. The timeline is ancient. The process is slow. Nothing intentional happened here. Nothing was cut. Nothing was removed. What remains is simply what resisted decay longer than the landscape around it. And yet the explanation begins to strain the moment comparison enters the frame. Why do so many of these formations share a silhouette that reads immediately as truncation? Why do the sides on some of them present long, bark-like fluting instead of the irregular collapse one expects from shattered stone? Why do isolated mesas, terroirs, and plateaus across different continents appear less like unique accidents and more like repeated fragments of one vanished class of object? The official explanation describes the material. It does not always satisfy the shape. It classifies what remains. It does not fully explain why what remains looks so consistently like something severed. So the hidden theory emerges, not as a tantrum against science, but as an investigative possibility that the record never seriously entertained. What if a category mistake sits at the center of this landscape? What if some formations now labeled as mountains, buttes, mesas, plugs, and monoliths are not merely geological structures in the ordinary sense, but the petrified remains of an older biological world on a scale no modern ecology would allow? What if some of the stone that surrounds us is not simply inert rock, but the mineralized residue of organisms so large they were later reinterpreted because there was no acceptable box left for them? Strange, yes. But the pattern begins where the labels stop. Start with form. A tree stump is not just circular, it is elevated, vertically sided, wider than it is tall, with exposed grain-like structure on the edge and a flattened upper surface where removal occurred. Many famous formations present exactly that sequence of features. Flat summit, sheer perimeter, vertical ridges, distinct base flare, detached position in the landscape. The modern eye has been trained to translate that shape into mesa, tower, escarpment, resistant cape rock. But language does not erase resemblance. The stone remembers. Even where erosion has softened the outline, the profile remains stubbornly stump-like, as though the accepted terms were laid on top of an earlier visual truth and simply repeated until they felt more natural than what people were actually seeing. Then there are the lines themselves. In a normal photograph of weathered cliff bands, the eye expects broken strata, angled fractures, talus piles, irregular interruption. But on certain towers and buttes, the surfaces display strong, vertical segmentation, parallel and repeated, almost vascular in effect, as if a fibrous structure had been mineralized and enlarged beyond common scale. Mainstream geology calls these columns jointing produced during cooling and contraction. That is a real process. Basalt columns exist, as a cooling rock can fracture into repeated forms. The question is not whether columnar jointing is real. The question is whether every bark-like wall has been correctly assigned to that process simply because the category already existed. Similar appearance is not identical origin. That is where classification becomes a habit rather than an answer. The record also contains older descriptions that are more suggestive than modern summaries allow. 19th century survey language often drifted between geology and architecture, between natural form and worked object, because observers were encountering shapes that did not sit comfortably inside ordinary vocabulary. They called places tuawas, walls, castles, chimneys, monuments, pillars, crowns. That does not prove the hidden theory, but it reveals something important about first contact with the scene. Before explanatory systems hardened, many formations were described by their visual contradiction. They looked built, they looked sectioned, they looked left behind. What changed was the explanation. The form did not. Photographs deepened the problem. Early images of isolated stone towers and flat-top mountains often include people, wagons, or small structures at the base, and the scale becomes almost absurd. Not simply large, anatomically wrong. These are not slopes gradually lifted from the land. They appear as cores. The summit often reads like a cut plane. The sides drop in a way that suggests exposure rather than accumulation. Even when the mainstream model can account for that geometry, and it does so by invoking a long subtraction of surrounding material, so total that the remaining object seems selected, almost curated, by erosion itself. That may be true in some cases, but when a process begins to explain every impossible-looking survivor by saying everything else vanished, it starts to sound less like observation and more like an all-purpose solvent. Look at the surrounding landscapes. Around many of these formations are beds of loose sediment, broken rock, sand, and layered debris spread over enormous distances. The orthodox reading is straightforward. Erosion products, marine deposition, river transport, glacial action, wind. Again, much of that is real. But there is another way to read the same field of fragments. If an older world of giant organic structures once existed and was shattered, cut, burned, buried, or mineralized, the debris field would not announce itself with labels. It would enter the record as gravel, ash, shale, lignite, coal seams, silica beds, strange soils, displaced trunks, petrified forests, compressed organics, unexplained layers. Matter does not disappear. It changes names. The record is still there. A fair objection has to be faced here. Mainstream geology is not lazy simply because it is mainstream. It has measurements, mineral analyses, field mapping, isotopic dating, and mechanical models that explain an immense amount about the Earth. Volcanic necks exist. Laccoliths exist. Differential erosion is observable. No serious investigation can dismiss that. But that same framework is strongest when dealing with process and composition, not always with the uncanny recurrence of form across categories. And if a massive petrified biological structure were completely mineralized, cut, compressed, heated, and reworked over long spans, many of its present-day properties would still look geological, because they would be geological. The disagreement would concern origin, not current material state. That is precisely what the official explanation tends to skip. The pattern widens when a single monument is no longer treated as unique. Devil's Tower in Wyoming is one case. But then there are flat-topped mesas in the American West, isolated stone tables in Africa, giant buttes in Australia, columned monoliths in Europe, circular highland remnants, plateau crowns, and cliff rings whose proportions repeat beyond comfort. Not identical, recurrent. Some are broader, some narrower, some deeply eroded, some almost cleanly preserved. So soon, but the family resemblance remains. The pattern does not disappear. Once the eye stops reading them as unrelated local exceptions and begins reading them as surviving fragments of a missing class, the map changes. Suddenly, the issue is not one strange tower. It's a global inventory of forms that may have been normalized by naming conventions, long before anyone asked whether naming had hidden a deeper continuity. Then there is the problem of associated legends. Cultures separated by oceans preserve stories of world trees, sky pillars, trunks that reach the heavens, roots that reach the deep, central stems around which order itself was organized. Scholars file these under myth, cosmology, symbolic structure. Fair enough, symbols matter, but symbols often begin in contact with something. A memory does not need to remain accurate in scale to preserve a real object as sacred exaggeration. If there once were biological forms so immense that later populations could only translate them into cosmic terms, then world tree traditions stop looking like poetic coincidence and begin looking like cultural compression. Not proof, but not nothing either. When physical anomalies and recurring myth point in the same direction, dismissal becomes less responsible than careful attention. Maps and land use records raise another question. Many isolated formations became immediate survey anchors, sacred sites, territorial markers, military observation points, or protected landmarks as soon as states expanded into their regions. That is understandable, they dominate the horizon. But it also means the surviving remnants of an earlier world were rapidly folded into administrative systems that cared about utility more than origin. Once something becomes a boundary marker, a national monument, a geologic exhibit, or a tourism asset, its classification hardens. Bureaucracy prefers stable nouns. Economics prefers marketable stories. School books prefer compact explanations. There does not need to be a secret meeting in a dark room for a strange object to receive a final label and then remain trapped inside it for a century. This is how large reinterpretations are often buried in plain sight. Not through dramatic conspiracy, but through institutional inertia. A surveyor uses the nearest accepted term. A textbook repeats it. A museum builds signage around it. A park brochure simplifies it. A grant depends on standard categories. A scientific paper narrows the question to measurable chemistry rather than origin. Soon the entire apparatus is aligned, not necessarily to hide the truth, but to make alternative framings feel unserious before they are tested. Classification becomes a gate. What falls outside it is treated as spectacle, then internet noise, then something unworthy of field time. The truth, if there is one, does not need to be suppressed. It only needs to remain unasked. There is also the issue of missing intermediates. If isolated towers and mesas are simply the final remnants of former layers, where are the expected transitions in every case? In some regions they exist, and the orthodox explanation works well. In others, the remnant stands with a visual decisiveness that makes the absent parent material feel less like gradual loss and more like radical removal. The surrounding terrain can look scraped, leveled, or reduced in a way that reads almost industrial at a planetary scale. That language is dangerous because it sounds excessive. But scale itself is the central problem here. Once the object is large enough, ordinary words fail. The mind reaches for the safe explanation first, not necessarily because it is better, but because it is survivable. Engineering analogies add one more unsettling layer. When modern people cut massive timber, quarry stone, or core earth for analysis, the resulting surfaces display repeated signatures, exposed vertical structure, flatter tops, abrupt edges, and residue fields around the operation. On a smaller scale, then, the visual logic is obvious. On a much larger scale, we are told not to notice the resemblance. Yet the resemblance remains. Not because nature cannot produce sharp surfaces. It can. Not because all flat tops imply cutting. They do not. But because repeated mechanical-looking outcomes appear across landscapes where the official explanation changes from case to case, while the visual anomaly remains strangely consistent. Different labels, same silhouette, same after-image. And what of petrification itself? The public imagination often treats petrified wood as a curiosity, a log turned to stone, rings preserved, cellular structure replaced by minerals. But petrification is already a bridge category, proof that the boundary between biological form and geological material is not absolute. Once that principle is admitted, May's scale becomes a disputed variable. We accept a stone tree trunk at the size of a log because it fits the museum case. We reject the possibility at the size of a mountain because it collides with the modern sense of what life is allowed to have been. Yet the planet's past is filled with scales that would have sounded impossible